Okay, so our group synthesized cadmium selenium dots, and we took the fluorescence and UV vis of these dots, and we also took the fluorescence and UV vis of the last group's dots as well, and we observed how much they degraded over a few weeks.
So some tips for when you're synthesizing your own quantum dots. We've realized that upsizing is a very good plan because when we took the UV vis, we had to dilute everything so much that our fluorescence wasn't as strong and our quantum dots just weren't as good after the dilution. Also, when you take your dots off of the heat for the aliquot taking, you're going to take them off the heat, but you want to keep it nice and close to the oil bath, otherwise you're going to change temperatures too rapidly and not get as good of a spectrum. Also, when you're taking your aliquots, you're going to base these aliquots off of time, or off of color, not time, because it takes a while for it to get going and then it goes really, really fast. And then these are very temperature dependent. So when you are opening and closing your hood, you want to keep it at the same level, otherwise your temperature is going to spike during the heating process.
So one thing the other group wanted us to look at was the long-term storage of quantum dots. So we just did a little bit of research. Our previous storage method was just putting them in a box, having everything labeled, and then putting it in a cabinet. And we found that that is not the proper way to store quantum dots. And the proper way is to store them at around 4 degrees Celsius in a dark space. So we talked to Dr. Rowley, and he said to just store them in the biochem fridge. So that's what we're doing right now. They will degrade pretty quickly, over a week, over 3 weeks, if they're not stored in proper conditions. So just make sure that's kind of at the back of your mind. The thawing process will take about 10 minutes if you're thawing it with your hands, and that's for about 12 aliquots. So just make sure you're planning out your time for that as well, and then make sure all of your quantum dots are labeled and you're labeling the box that you're using as well, so none of the other science professors get nervous about what's in the box.
So now that we've talked about what we did and some tips and stuff that we learned throughout our process, it's time to get into what you guys are doing. So the big end goal for this project is ligand binding these quantum dots to cells, and we're thinking yeast cells just because they're more affordable and a little bit easier than actual like animal tissue. So we did research for you guys based off of yeast cells, but if for some reason this doesn't work and you have a greater interest in animal cells, you're more than welcome to do that. But like I mentioned, it is more difficult and you'll have to talk to the biology department a lot. So anyways, this is all about yeast cells. So like I said, your end goal is to bind these quantum dots to these cells so their fluorescence can be used to mark these cells. So we found a ligand binding article to yeast, and that describes, once you have your quantum dots, how to get them attached to the yeast cells. So like Marie mentioned, we did cadmium selenium dots. Unfortunately, this procedure uses cadmium selenium zinc sulfate dots. So you can't use the same quantum dot procedure that we used because you're making a different type of dot. So we found 3 different procedure options for you. Most of them have the calculations already done, which is really, really nice because getting the things to temp consistently does take about an hour of your lab time. So it's nice to not have to do all the math or troubleshoot if the grams are too small and such. So like I said, we have 3 different options for you. So feel free to look through those, find which one you think would suit you best. And if you don't like any of those, you're welcome to find another one. We just thought we would give you a little bit of a head start. But looking at those, it did seem very similar to our synthesis of quantum dots, basically just using different chemicals. So the tips will probably still apply to you. And if you have any like additional questions or like you want more clarification, please feel free to come and ask us. But our biggest I guess, suggestion for you guys is these quantum dots take about a whole lab to make, but if possible, take the fluorescence of them like the first day, because like we mentioned, they do degrade even if you store them properly. So if you can take the fluorescence the first day that you make them, you do have to get them to room temp at least before you can do this, but if you can take the fluorescence the day that you synthesize them, that will give you a really, really good idea of if you successfully synthesized these quantum dots. And obviously you don't want to waste time using quantum dots that aren't actually correct. So this will really help you figure out if you're on the right track. So that is our biggest suggestion, and this is what you guys are picking up. Have fun.